This is a video to go over lesson 1, so section 2.1 of the textbook, titled the tangent ratio. So the definition of the tangent ratio is shown in this first box here. So let's look at what we're seeing here. So we're going to be studying right triangles in this unit, and specifically we're going to be looking at the ratio of the different side lengths in the triangle. So when you have a certain triangle with an angle here, so the angle I have labeled or indicated here is angle A because it's got this little angle symbol here. So we're focusing in on angle A, and we're going to label the different sides of the triangle based on where angle A is. Okay, so if we're thinking about angle A, the side that's opposite to angle A, so directly across from it, so if you were to draw a line straight across, we call that the opposite side. I'm going to label that in a different color actually, so that we can see it in the equation. So I'll label in green. So this is the opposite side, and notice it's here in our formula. And the side that's right next to the angle, okay, but not the hypotenuse, the other side, is called the adjacent side. So we'll label that in pink here. So this side is right next to the angle. So a fancy word for being next to it is adjacent. And so we're looking at the ratio between these two sides. So let's say angle A was 60 degrees. Then for any triangle with an angle of 60 degrees, this ratio, when you divide the opposite side by the adjacent side, it will always be the same. So over here I have a picture of a much bigger version of this triangle. It would have the same ratio as long as this angle is the same. It would have the same ratio of the side lengths. Even if this would be true if you made the triangle much smaller as well, as long as you keep that angle the same, the ratio of those two side lengths is going to be equal. And this is going to help us find out what the angle is, or in another lesson we'll use it to determine a missing side length as well. Okay, so let's first practice how we set up our ratio. So this question says, determine what tan of D is and tan of F. So we'll start with tan of D. So tan of D, the formula is we want the opposite side to angle D, and we want adjacent to angle D. Okay, so the opposite side, I used green before, so I'll use green again. So here's angle D. The opposite to angle D would be 3. Okay, and then adjacent to angle D would be 4. So adjacent again means right next to. So if I was going to set up the tangent ratio for D, and we use the word tan, I forgot to say for short, but the full word is tangent. So we call this the tangent ratio for angle D, and it would be the opposite side, which is 3, and the adjacent side, which is 4. Okay, so now let's do the exact same thing. Sorry, I forgot to label my side lengths here. For angle F. Get my pen back. Okay, so for F, the side lengths change. So the side that's opposite to F is now the pink side because it's directly across from F here. Okay, so and then the adjacent side to F is the one right next to it, would be 3. So tan of F would be 4 over 3. Okay, and no matter what size triangle you have, as long as those angles stay the same, you would get the same ratio of side lengths. So you'd still get 3 to 4, or 0.75. You could write it as a decimal as well. Okay, so yeah, I'll just show that as well. So sometimes you'll see these ratios written in decimal form. So 3 divided by 4 is the same as 0.75. So you might also see a decimal written like that. And then 4 divided by 3 is 1.3 repeating. Those are the same number. Okay, so now it says use the inverse tangent function to calculate the measures of angle D and angle F in degrees. So this is where we're going to actually use this formula. So if we know the two side lengths there, we can actually calculate what the angle is, and our calculator will help us do that. So we have, so for angle D first, what we found out in the previous part was that tangent of angle D is 3 over 4 or 0.75, either one. So if I want to actually calculate what this angle is, I'm going to use the inverse tangent button in my calculator. So it looks like this. So a little -1 in math often refers to an inverse, so like an opposite function button. So here we're going to press the inverse tangent button because we're going to find the angle that's inside here, and we're going to type 3 over 4. So let's see how that looks. In this calculator that I have to type 3 divided by 4 first, and then I'm going to type the inverse tangent button of that. So you might look for this button. You might have to press shift. I have to press second here in my calculator. We're going to press the inverse tangent and see I get a long decimal there. So it's not an exact answer. We're going to have to round it off, but my question says to round it here. So it says 36.86989, etc. degrees. And we're rounding to the nearest degree, so it'd be 37 degrees. So I'm not going to use an equal sign. I'm going to use a little squiggly equals, meaning that I've rounded off. So that's my final answer. I'm going to box it in. So angle D here, I'm going to draw it in here, would be 37 degrees. Let's do the same thing for angle F. So we could subtract from 180, and we'll do that as a check as well. But for now, we'll just use the tangent ratio. So tan of F equals 4 over 3. So we're going to do the exact same thing. F is going to be the inverse tan of 4 over 3. So F, and we're going to have to round it off again. So let's see how that looks. So clear everything. 4 divided by 3. So in your calculator, you may have to press that first, or you may press tan minus 1 first. It just depends. So here I'm going to use inverse tangent, and it's 53 degrees approximately. So there is another check you could have done. We practiced in the Get Ready assignment to find out that all the angles in a triangle should add to 180. So if we did 180 minus the two we already had, 90 and 37, we would have also gotten 53 degrees. So it's kind of two ways to get that angle F. Okay, so that's how to use the tangent ratio to calculate a missing angle. You're going to do the exact same thing in the next example. So feel free to just pause here and do it on your own if you feel confident, or you can do it along with me. So first we'll start with angle G. So angle G is right here. So let's label the sides. So the side that's opposite to angle G would be 4. And the side that's right next to angle G, which is called the adjacent, is 5. So tan of angle G, it's always the opposite side over the adjacent side. I'm just using OPP and ADJ for short. So the opposite side is 4 and the adjacent side is 5. So when I want to calculate angle G, I do the inverse tangent function of 4 over 5. So let's type that in. Clear everything out. 4 divided by 5, and then the inverse tangent function of that. So it's about 39 degrees. Now I have two choices here for angle J. I can either do the same thing again, or I can just subtract from 180. I find it slightly faster to subtract from 180, so I'm going to do it that way. So I'm going to take 180 minus the 90 I already have, and minus the 39 I calculated for angle G, and I will get 51 degrees. So angle J is equal to, I'll put a little squiggly because it's not exact, about 51 degrees. So this one here is 39, this one here is 51. And that is the end of the lesson. In the next lesson, you'll be finding out how to calculate a missing side length given an angle and another side length.